Continuing with my voiceover because of a muted microphone. Now let's say that we have to solve a very similar inequality. Absolute value of 7x is less than 28. One approach would be to pretend as if we have an equation. The negative 4 and 4 that we found in the previous question would act as boundaries between where solutions are on the number line and where we have non-solutions. So I'm going to mark off negative 4 and positive 4, as well as some points in between and to the outside, both in the left arm of the number line and the right arm of the number line. It's a bit of overkill, but I'm going to check both, one that's in between and one that's in the left arm and one that's in the right arm. If we pick 0 in between, 7 times 0 is 0. Its absolute value is still 0, and that is less than 28. So x equals 0 is one of the solutions, and if we pick anything in between negative 4 and positive 4, those will also check out. They'll make the inequality true. That would mean anything between negative 4 and positive 4 is a solution. Whereas if I test 5 to the right of the largest boundary point, we get that the absolute value of what was inside is 35, and that is not less than 28. So 5, or anything to the right of the boundary point 4, is not a solution. You're going to get the same thing when you plug in negative 5. The absolute value will come out to be 35 after you've applied that positive value. And so negative 5 or anything to the left of negative 4 will not work as a solution to the inequality. So we're just taking what's in between. Because there was no or equal to bar, we have parentheses there. So what we're finding out is that 7x is between negative 28 and positive 28. You divide both sides, well, not both sides, but all three parts in that compound inequality by 7 to get the same result. Could add a little extra window dressing around that to get set builder notation. In interval notation, parentheses, negative 4, comma, 4, parentheses. Again, the parentheses because of no or equal to bar. And for short, here's a rule that we could apply anytime you've got an isolated absolute value less than or even less than or equal to a positive number.